Did it start? Still says it's
Yep.
not. Okay. Hello, everyone. Today is Tuesday, which means we have core protocol sync today. And we'll go and share what we've been working on the coupled execution, consensus side, a little bit on the farming side, I guess, those kinds of things. Lucian, let's probably start with you if you don't mind.
Okay, sure. Actually, last week, I only have one bug fix PR submitted to the main branch. And let me share my screen. Okay. This PR is intended to fix the fraud-proof reports. There are two things, actually. One is previously we use the block number associated with the hash in the receipts, which is wrong. We should use the block number at which this receipt was created at. Yeah, this is one thing. Another thing is that while we are when the external receipt has been received, but the local receipt is not ready, then we need to wait for the local receipt, right? While we are waiting for the local receipt, we should also check if the local executor has progressed to the next block or a higher block. If it's true, that means we have a mismatched execution receipts, and we should just return the receipts at the same block number locally. Yeah, otherwise this loop will be endless. And yeah, basically two things in this PR, and no new features was submitted last week.
So that's all fixed now?
Yeah, seems to be fixed right now. At least it works when you run the local development environment.
It is fixed enough, but there are new to-dos.
We need to test more cases, how it works, under the primary chain folks. That is kind of uncertain. Yeah, we need the test framework to test those cases.
What are the other to-dos? Is it just test cases?
The to-do? Yeah.
When is you said there were some to-dos.
Yeah, so this is the first to-do that I had a concern about. So when you have a primary chain fork, right, and one node produced execution receipt for one fork, for one branch, and the other node is on the different branch, and that different node receives execution receipt, right? When it moves past this best block, the line 299, it will actually not be able to verify that other fork because it doesn't match the local execution receipt. So it will reject that receipt. But if later reorg happens, that execution receipt is already lost. So it will not be able to verify whether that execution receipt was correct or not correct. And I was suggesting that we probably need something like orphan execution receipts, kind of like with branches we have, right? One is canonical, the other ones can be non-canonical, and there could be some blocks which are just flying in the air waiting for other blocks to arrive. So we probably need something like that for these execution receipts, so we can wait for a little bit if they happen to be useful a bit later, instead of just skipping them altogether. So this works until if you don't have primary forks. If we do have primary forks, I don't think it will work correctly. It might work, but it will not verify something.
Actually, even you have the primary chain forks, if the local executor also reorgs in time, actually it still works.
Yes, it will work, but you will effectively not verify the execution receipt that you received from another node. You will not be able to like equivocate that node if the receipt happens to be incorrect. You'll just skip it. Ideally, you would wait, and as soon as we reorg to that branch, you will like re-verify these execution receipts.
I can't give a 100% answer. I don't have one. We need to
Does it make
Doesn't-
sense?
Sorry. Go ahead, Li Chen.
We just need the test framework to test this, like to work the environment to test in those cases.
Yeah, I mean, it makes sense what you're describing, but I thought that that was already handled because I thought that the fork tree in Substrate maintained both forks until one was pruned, and so they could both be maintained.
Fork tree, yes.
independently.
We are talking about execution receipts, which are broadcasted out of band, like a separate thing on the network.
Right, but the fork tree, but you would have execution receipts for both branches of the fork.
Right, and here we're just checking what is the best number. And as soon as one of the branches moves beyond a certain block height, we just reject all of the ERs which are for the older branch.
Oh, so you're saying that the secondary chain doesn't, or at least when we receive the new ER, when we receive ERs over the network, we're only looking at the longest chain that we see. We're not tracking it across all chains on the fork tree.
Yeah.
Oh yeah, that's definitely a problem that we have to fix. No question. That's the way it has to work.
Yeah, we need a proper plan for that.
Well,
Yeah, I think it will be easier to reproduce if you have test framework. We can just simulate the
Yeah.
situation and see what happens, and then we can fix it and
Yeah.
have a regression test.
Yeah.
so okay. So whenever we receive a new execution receipt, can't we just walk the fork tree and see if it corresponds to any best block or anything that's not already been executed or confirmed, so to speak, by the execution receipt?
We can, however, we don't know if that other fork will ever actually be present on the current node. So we can just run this loop forever, waiting for that to happen.
Don't know if the other fork will be present on the current node. The other fork of the primary chain?
Yeah, the other branch. Like
Well,
maybe it
wouldn't
will be turned off before this node even recognizes it exists.
What is the pruning role right now? How many blocks does it have to be deep?
Honestly, I don't know.
The unsolent, we only prune the ERs and the associated data if the depth is over 1 solent blocks.
1,000?
Yeah.
I mean, just forget about ERs or secondary chain. How does, like on the farmer chain, like just in default substrate, how long does it take before it will prune a fork?
I believe
So
it's a
does it-
parameter in runtime. Let me
Oh,
check.
okay. Okay, I think another thing.
If that is what I think it is, block number, block length. $250. Maximum number of block number to block hash mappings to keep. I think maybe this is it. Maybe it's not it. I think this is it.
Okay, so if it's 250, then almost certainly if there's a block, if there's a fork, it'll be received. You know, the fork will be will stop propagating before. Like you won't get to that point where there's this infinite loop because the forks will propagate, the ERs will propagate, but eventually people will stop building on the forks. The network will
Right, but the
converge.
current check
one
is
house to one.
just for the height of the past chain.
Right, right, I understand. But that infinite loop, I mean, that should not occur.
Right. It shouldn't occur, that's for sure.
Okay. Okay, Liu Chang, can you create an issue to track this in the repo? This is, or I guess, how are we tracking this right now? This
To
task?
do in the code.
Okay, yeah, let's try to get away from that and put this as an issue in GitHub.
No, it's actually
Okay.
better to have to-dos, honestly. Like we can have both for like big things, but to-do is in code is very crucial, I think.
How do I
um,
how do I know what all the to-dos are in the code?
How
does
I
a
don't think you
project
need
manager know what
all
all
the
the
to-dos.
to-dos are?
You need all of the big tickets. But
That's a
if you
big
don't
ticket.
have to-dos in the code, like code can move, and then we have this disconnect between tickets and the code base. So we need to have an anchor there, I think.
Well, what qualifies as a ticket?
Well, this clearly qualifies, but we have some smaller to-dos.
Okay, I think I'm not saying all to-dos need to be
Okay.
is tickets, but this is a to-do, which should be a ticket.
Okay. I'm just saying, like, let's not remove to-do because we have a ticket.
Oh, I didn't say remove to-do. I just
Okay.
mean we need a ticket. That's all.
Sure.
Actually, like in the practice of Substrate, they have an issue, they have a ticket, and they also have a to-do in the code linked to that ticket.
That's ideal.
What's the difference between a ticket and an issue?
Okay, a ticket is an issue.
Okay.
In my word.
Got it. Got it. Okay. Okay. So it supports, so it doesn't support forks, but it will need to. So we're going to fix that. And then,
Yeah.
What else? You stopped sharing, Liu Chang. Did you have more to present?
Nope, that's everything I submitted to the repo last week.
Okay. So right now, you will, so this is, so there's a fraud proof that gets generated and it gets sent.
Yes, in the normal case, no edge cases.
What is the normal case?
That is we ignore the forks, like if no forks, if the invalid like computation occurs, we will have a report.
Okay. And there's a test case that creates an invalid computation.
I tested this in the local environment. Yeah.
Okay. So you manually generated it. You had
Yes.
2 executors and one generated an invalid ER.
Yes.
And then what happened next?
You mean my job in this week?
No, sorry. So I guess I'm just trying to understand what point the implementation is at. So we can detect an invalid ER and then some other node generates a fraud proof.
Okay, yeah, the next step is to generate a fraud proof. Yes.
So all we can do is detect fraud proofs right now. We can't generate fraud proofs.
Yes, we can't.
I see.
We can't generate the proof.
Okay. Because like make the fraud proof work made it sound like there actually was a generate, but it's really just detect fraud.
Yes.
Okay. Okay. All right. And what is there anything blocking that task right now of generating the fraud proof?
Yes. As I mentioned before, I thought it worked, but the test case I like imagined, they have a mismatched results. So yeah, I haven't like looked into this. I believe I'll back to this after the test framework.
Oh, so we still don't know why we're getting invalid I thought it was because of the intrinsics in the with the timestamp.
No, nope, not that's another issue. You are talking about the fraud proof generation, right?
I
The
don't know.
fraud proof generation is like essentially the intermediate storage proof, right? We need a proof for the extrinsic or the invalid extrinsic state, like a transition, right? What we want is actually this one. And
Right.
yes, as I mentioned, like previously, I was like planning to reuse the pattern of block like proof, the block
Right.
execution proof, but that way like doesn't work due to the overlay, the optimization of the implementation. But it actually works for the first like extrinsic execution. So I thought like I can use those two ways to produce the proof for the first extrinsic, so I can compare the proof if they produce the same result. Like if the does like produce the same result, like I can be assured that like the way is basically correct. But they have a different result for the proof.
Okay. So when the executor generates, when the executor executes the block with one transaction, they get one storage root. And then when you try to rerun it as part of the fraud proof generation, you get a different storage root for that transaction.
Yes.
And we don't know why.
Yes.
Okay, but you do
I
insert.
tried to inspect like all the whole like storage changes. Like they have a few like storage keys have different storage value. I have no idea what these like storage keys are. Like I can only like tell one storage value, which is the extrinsic index. The other ones I have no idea what do they like represent actually. So
I think I know. So in the block initialization, you are erasing the like vector or set or whatever of the intermediate state roots. If you don't do that, then the first transaction will be run against the state, which does
nope,
contain
nope,
this.
nope. I actually like try to generate the proof exactly before you execute the first extrinsic, which is after the initialized block. The current in current substrate, you can reset the like proof recorder anywhere. So I just like before you execute the first extrinsic, I reset the proof recorder, which will record all the storage values, the storage keys like attached during the execution. And after the extrinsic execution is done, I convert this like storage proof into the final proof. So it has no initialization related. Actually, maybe this.
Maybe can you show us the code for how this is working?
Yes. I'm just 1 second.
Yeah.
The discussion maybe can I explain better. The shared in the message. So based on the feedback of Bastian, there is seemingly like no logically error here. So they should be the same, I believe, but the fact is not. If there is like obvious logical like error, I believe Bastian will find it, but it's not.
I still don't fully understand how the uninitialize is not an issue, honestly. Like we do erase the vector and then we also insert one item, I believe, before the first transaction. So there are some changes if you just like if this prover assumes that on initialize doesn't change anything, but it shouldn't really. It may arrive at
Well,
different conclusion.
which depends on like if you like if you initialize the recorder, the proof recorder, like at the same time, at the exact like starting point, and you have an exact same ending point, all the like storage keys, storage values touched in this like execution should be the same.
Okay, can you
right?
show where you reset it or how you call it?
Yes. Okay, this one. You call this method API dot record proof, which is to reset the proof record to the default value, which is kind of like a reset. After that,
Where is
after that-
block initialization?
Lucien, could you just share your screen and walk us through instead of
Yeah,
dropping
yeah,
all these links in the chat?
sorry.
It's just kind of hard to follow. Maybe you could just kind of start at the beginning because I'm kind of lost right now as to what's going on.
Sure. No problem. So shall we start from the initial?
Let's just start with the code. Maybe if you could just kind of explain, like at the beginning, fraud proof,
Yeah.
like how you
Yeah.
generate the storage proof, like in the code, but not taking us through all this.
Can I ask
just
a
so we can
question?
see it in context. Yep.
So this is the block execution, right? The first extrinsic execution proof.
It's inside the block execution.
So it just calls into regular block execution, where you have these like commands, which are only used when you actually generate the proof, right?
So come again?
So this line that you have 240, is it only working when you're trying to generate a proof and otherwise it's useless?
Nope. It works like during the entire like block execution.
Right, but if you're not trying to prove anything, why would you run it?
I like proof. I generated the proof here just right after you execute the first extrinsic. This one
Right,
is
but
to
if it's
generate the
general,
proof.
like regular execution, why do you need a proof if you're just running it? Seems like a waste of resources.
No, I just want to like to compare the proofs generated using
Okay.
two approaches.
So
I
just for
think
testing.
they should have the same proof result, right? This one is the new approach. I think it should workable. I just want to ensure will generate the same results like with this approach. I think they should have the same like proof results. Logically, they should just be same.
Can you start at the beginning, Li Cheng, and just walk us through what's happening?
Okay. So in Substrate, it has a proof recorder, which is like if you call this runtime API, record proof.
What part of the execution workflow are we in right now in the protocol?
Okay.
Are we in the block execution pipeline?
Yeah, we're currently in the like we are executing the extrinsics, right? We have all the extrinsics, right? And we execute one by one.
Okay, so all of the bundles have been included in the primary chain. Farmers have created a primary chain block. Executor receives the primary chain block, so now it knows the order of execution. So now it's going to actually prepare the extrinsics and execute them one by one. That's where we're at right now.
Yeah.
Okay, got it.
This is the final like extrinsic list. Okay. The normal way, we just like execute them one by one. And if we find any like invalid like state transition or like different like execution results, we may need to rerun, right? And generate a proof accordingly, right?
Well, that's step 2. That's on the validator, but first we're on.
Normally, we don't have to generate the proof.
Right.
We only generate the proof when you might detect an invalid state transition.
Right.
Yeah. So this is in the normal way. We don't generate the proof.
Okay. Sorry, can you go back? So where is the? Okay.
So this is just the like the normal way we generate all the. Okay, we execute all the extrinsics without generating any proof. So this is one. And
hold
if
on.
we wanted to,
I'm just reading through that really quickly, just so I understand what's going on here.
Okay, so this is the final extrinsic list,
right?
And we execute them one by one. This is the whole like logic for the block extrinsic.
Okay.
Block execution. Right. Yeah.
And from substrates, from the internals of substrate, each time we execute an extrinsic, or sorry, we don't update the storage overlay until we've executed all the extrinsics?
Nope.
In substrate, or we do it one by one?
But they need to store it somewhere.
Saying, do we when do we update the root of the Merkle Patricia trie or the state database? Is it extrinsic by extrinsic, or do we apply all the extrinsics in the block and then we update in mass at the end?
Extrinsic by extrinsic.
That's the way Substrate does it by default.
No.
That's what I meant. Okay, so we had to modify Substrate to do it that way. Okay.
After every transaction, the root is collected. Like normally it is not, but we do collect it.
Okay.
Okay, so this is the normal like execution pipeline. And if we wanted to like, for example, we wanted to generate like if they like a forced extrinsic like execution results, like we have a different results for the forced extrinsic. We would like to generate the proof for the forced extrinsic rights. Just an example. If we want to generate this like first extrinsic execution proof, like before we execute this extrinsic, we start the proof recorder. After we execute this like extrinsic, we convert this proof record to the final proof, which the proof record actually like will record all the storage keys like you tested during the extrinsic execution. You read like write into this state. So
What
this
does the record proof look like? What's the shape of the data?
okay, so maybe we should proof recorder. The actual isn't actually this one. But okay, size.
Hmm.
Okay, actually it's just a hash map, like record the storage key hash and the associated like storage value. That's the hash map, which records all the storage like you touched during the execution.
And what are the values?
The value is the storage value. Like the blockchain is a key value database, right?
Where's the witness?
The witness will be like constructed proof. Yeah, a proof.
So we're even before the witness, and you're still not getting the same values. We're just looking at the records and the keys and the values, and those are not matching.
Um, the proof actually are composed of all the like storage, like you read and write during the execution, right? If we have all these like channels on the like storage you test during the execution, and we have the state before the execution, we use this storage proof to reconstruct the partial tree, the partial tree, right?
You said
And
it
we know
includes
this
the
state.
reads?
Sorry?
Yeah, you said it includes the reads as well?
Yeah,
Yes, you need inputs to transaction.
Yeah. You need the reads and the writes like during the execution. The storage value you read, the storage value, the story that you write, like during this extrinsic execution.
Oh, so you mean the read is like the initial storage value, and then the write is the final storage value?
Nope.
No.
No, so reads is what transaction will use to actually do the computation. Like if it reads some key, that key will be embedded as part of the proof, and there will be a proof that that key is part of the previous state root.
That's what I mean, the initial storage value.
Yes. Okay.
Okay.
Yeah.
Okay.
Okay.
That is okay. You mean
So the proof is
value before-
initial
okay.
storage value, initial storage root, final storage value, final storage root, and a Merkle proof.
Final value is not
each.
necessary. We just can compare the roots. That's what it matters.
So actually, you only need this like storage, like required for all the attached like during this execution and the states before the execution. You can compute the state after this computation, right?
Oh, sure. Assuming you have the state transition.
Yeah.
Yeah.
Yes.
Okay. Oh, so these storage proofs assume you have access to the state transition function for
Mm,
verification.
you can verify this state transition with this storage proof.
Okay. So just so I understand this, the context of this storage proof or the way that this engine has kind of been written is mainly to support POV blocks, right? A lot of this API.
Yes.
Okay.
The POV block actually just like the traditional block plus this proof.
But the POV blocks are intended to be done once, like all the initial inputs and then the initial
Right,
proofs
for the host block, yeah.
for the whole block,
Yeah.
right?
Yeah.
Okay.
Yeah. So I wanted to use like this approach already supported in Substrate to generate the proof for the first extrinsic. That's my initial idea. Yes. So this is the first approach, but it doesn't like work anywhere. It only works for the first extrinsic because the overlay doesn't record like the further like storage if you have like multiple extrinsics, they will be cached and won't be recorded in this proof. So it doesn't work for like multiple extrinsics if you have the same storage value, the same storage shared between like all they used in multiple extrinsics. This way,
Okay, so you need to have to write some additional logic to handle that.
Nope, this way just doesn't work due to the overlay. So this is my second attempts. They have like
Why doesn't it work?
You need to regulate the proof right, and we can have like any extrinsic can be invalid, right? We need to be able to generate the proof for like any extrinsic, right?
So you basically need an overlay for overlay, because if overlay has read something already, it will not read it second time.
Yeah.
So there will be no like record about that.
What is the overlay?
It's an abstraction on top of the state that caches changes during the block
It's a
execution.
cache like will be valid during the whole block execution.
A cache of the updates to the state?
Reads and writes. So reads will be cached, and writes like and if you read something that you've just written, you don't need to like read it from state. Just general cache, and then it will be flushed, like all the modifications will be flushed at the end of the block execution.
Okay.
That's at once.
And what problem does the overlay solve? Is it just an optimization?
Yeah, it's an optimization.
Okay. Does the overlay actually add more overhead in our particular style of incremental state updates than it would in a all-in-one for all the transactions in one block?
I don't think so.
Okay.
Like if there is no overlay, then every read will have to reach to the disk, and every write will have to reach to the disk and be flushed. So batching at the end all of the writes and caching all of the reads actually makes a lot of sense.
Okay, but the overlay is just like an in-memory cache. It's not part of the actual cryptographic database structure.
Of course. It's like a proxy.
Okay, so why do we need an overlay of the overlays? then?
So if you execute two transactions and both of them read the same state key, the first one will read it, the overlay and this proof recorder will record that you've read it, so it needs to be included in the proof. When second transaction runs, it already is in overlay. There is no record about the transaction needing that key. So if you start recorder after the first transaction, from what I understand, it will not record that that key was read actually.
Yeah, that's the problem.
So you basically need overlay for every transaction on top of regular overlay. So we can like intercept, or like we need some kind of custom overlay that can intercept those things.
Yeah, it sounds like we need a custom overlay. Because shouldn't it
Actually,
just be able to read the
you,
last
you
item
have
in the
another
overlay?
way. You have another way out. That's my second.
So is this why it's not working? Because
Yes,
it doesn't.
Yeah.
Okay,
That's
so we
why
know
it
why it's not
doesn't-
working, because you made it sound like it was still unknown what the
Well,
bug
we
was.
don't know why the first transaction doesn't work. We know why the second will not work.
Oh, okay. So the overlay shouldn't affect the first transaction, and that's still failing. Okay.
So the second approach I like discovered is they already have the support for the light client. They provide a method to prove the execution, like for the light client, which I believe is usable. It's just like useful for oral case. Okay, so this approach. Okay, this approach. Okay, this one. Okay. The substrate already provide like this approach, which you can like you can provide a proof for any like method with the argument. You can provide a proof for this execution. Like you have a function and the related argument. It already provides a way to generate a proof for this execution. And we can use this for our case. The apply extrinsic is actually this method. The argument is the encoded like extrinsic. So the only one we need to patch to the upstream is this overlay changes. We need to construct like the one from the block from the beginning of the block execution until like this extrinsic. We need to accumulate the changes as the like initial overlay changes for this extrinsic like execution proof, which is hard coded in Substrate right now, but I have patched them like to make it work. So this way it already works. I just want to ensure it produces same proof results with this approach.
So when you say it works, you just mean the code compiles and it runs, but you
Yeah,
don't actually get the same result.
Yeah, I can have a proof like from this one and then this one, but they doesn't match.
Those
I
don't
guess we
match
have
either.
just a few minutes left. So we'll probably not go through all the changes.
Okay, so just so I understand, so both methods don't work. They both produce two different.
This approach should work for any kinds, like for any position in the block, for any extrinsic. This one should be work. Yeah.
should work. So we haven't
Should
actually tested it yet.
Yeah, we need to test it and ensure it does produce like proof we expect.
Okay. And can you just test that manually like you did with the other one?
You know, this is the way I tried. I wanted to compare these like results from these two approaches. If they like have the same results, and they definitely like they'll be correct. Otherwise, I'm not sure. Like,
Well, how do you know which one is returning the incorrect result? Is it the original execution or is it the verification trying to produce the fraud proof? They're returning different. You know, one of them can be wrong, but we don't know which one.
yeah. So that's my current issue.
Okay. Okay. Well, let's continue this discussion on Discord, or I guess in the issue. But it just feels like we've been blocked on this for a while. And I mean, if we don't solve this, like, Subspace doesn't work. Bottom line. So this is like a big deal that we got to figure out. You know what we can do here to resolve this.
Yes. The whole context, the whole context is basically this discussion. I have
Okay.
really detailed like information here.
Okay.
Well, you
Can
can
you-
create a ticket and link to this discussion.
Yeah.
Okay, sure.
But I just don't want us to be blocked by like parity. Like we got to figure out ourselves like what we're
Yeah,
doing
yeah,
with
yeah.
this, or like
So,
what are.
so yeah. So I want to like to really look into this after the test framework. Yeah.
Okay. I think we're gonna have to drop off at this point, Nizar.
Yeah, I think
Sorry guys,
on my side there
out of time
wasn't
today.
much happening. I think we can cover everything next time together.
Okay. All right. Thanks for going through that in detail with us, Li Cheng.
And thanks everyone for watching on YouTube. See you next week.
Bye guys.